Hello everyone, myself Ashwin Chauhan. Welcome to another video of data science series. Today we are going to solve our end semester examination question paper. So let's start with a question number first. How unstructured data is transferred into a format suitable for machine learning modules. Unstructured data such as text, image, or videos must be converted into structured numerical formats or machine learning. The steps include text cleaning, remove irrelevant character, punctuation, HTML text, etc. Convert text to lowercase, tokenization, split text into individual words or tokens, stop words remover, remove common words like the, is, etc., which do not add significant meaning, lemmatization, steaming, reduce words to their root for forms. Example runnings run. Feature extraction. Use techniques like TF, IDF, convert text into sparse numerical vector weighted by term importance. Word embedding. Dense vector represent re- dense, dense vector represent example word to vec, glow way, BERT. Structure format represent data such as numerical vector or arrays for machine learning algorithm. 2. Step 2. Importance of legal classification in gr- grievance redressal. Legal classification play a crucial role in grievance redressal by streamlining process, automates categorization of complaint into appropriate legal categories, example IPC section, improved accuracy, reduce human error in classifying complaints, faster resolution, prioritize and routes complaint to the correct department, ensure fairness, provides a consistent handling of grievance, enhance scalability, handle large volume of complaint efficiently. Third step, how TF and IDF or words embedding can be used to extract feature from a complaint text. TF and IDF. Purpose. Identify important words in the complaint by assigning weights based on their frequency in the document and retrieve across the corpus. Example for the complaint, theft of my mobile phone. TF and IDF highlights theft and mobile is an important term. Word embedding. Purpose. Map words into dense vector capturing semantic relationship. Example, words like theft and robbery will have similar embedding allowing model to organize better. Both model method help in transforming complaint text into a format suitable for machine learning classification. So this we discuss our question number one. First, let's discuss question number two. Life cycle of data science project. This step include stage, objective, key detail task, and tools libraries. First, define the problem. Clearly understand and define the business problem or research objective. Problem, key task, problem statement, expected outcome, and scope of the project. Library or tools, problem specific discussion. Data collection. Gather data from relevant sources. This is the objective of data collection. Task. Collect structured, semi-structured or unstructured data. Tool. SQL, APIs, web scraping, Python, pandas. Stage 3. Data exploration and pre-processing. Objective. Analyze and clean data to make it usable for modeling. Task. Handling missing values, outlier detection, and exploratory analysis. Library or tools. Pandas libraries, Python or Matplotlib, Seaborn or R. Stage 4. Feature engineering. Objective. Select or create a feature to improve model performance. Task. Feature selection, extraction, and transformation. Library. Python, sklearn, or feature tool. Stage 4, 5. Model selection and building. Objective. Choose and build machine learning model based on problem. Task. Select algorithm, train model, and tune hyperparameter. Library or tool Python, Scalar, TensorFlow, or PyTorch. Stage 6, Model Evaluation. Assess the model performance on unseen data. Task. Use metrics like accuracy, precision, recall, and F1 score. Library Python, sklearn, or Matplotlib. Stage 7, Model Deployment. Objective. Deploy the model into a production environment for a real world use. Task. Use API, cloud service, or edge device for deployment. Libraries or tools, Flask, Fast API, AWS Docker. Step Step 8, Monitoring and Maintenance. Objective. Monitor the deployment model's performance and update as necessary. Task. Track drift, retrain model, and handle feedback loops. Libraries and tools, Parameters, Grafana, Python script. Now let's discuss our question number 3. Explain the role of text mining in automating grievance redressal system. List the key steps involved in pre-processing unstructured text data. Role of text mining in automating grievance redressal system. Text mining automates grievance redressal system by extracting meaningful information from unstructured text data. Example, complaint feedback. Here is how it contributes. Automate categorization. Text mining classified complaint into predefined category. Example, service issue, theft, etc. without manual intervention, helping route them to right department quickly. Sentiment analysis identifies the tone of complaint, positive, negative, natural, enabling prioritizing of urgent or high priority issues. Efficient query handling automatically identify key information, example, complaint type, location, issue to resolve queries or trigger appropriate action. Pattern recognition detects trends or recurring issues, helping to improve service or resolve frequent grievance. Improved accuracy. Reduce human error in interpreting or classifying complaint, ensuring consistent response and efficient problem solving. Key step involved in pre-processing unstructured text data. In brief, text cleaning. Remove unnecessary character punctuation and special symbol and convert text into a lowercase. Tokenization. Split text into individual words or token for further analysis. Removing stop words. Remove common words, example the, is, that doesn't contribute significant meaningful. Send. Stemming lemmatization. Reduce words to their root form. Example running is convert. Changes to run to normalize variation of the same word. Vectorization. Convert text into a numerical format using method like TF, IDF or word embedding. Example word to vec to prepare data for machine learning model. So the steps are essential for transforming a raw unstructured complaint data into a clean structured format suitable for automated processing, classification, and response generation. So this is all about our question number 3. Now let's discuss our question number 4. Explain the key difference between k-mean clustering and hierarchical algorithm. What are what 10 are the advantage of hierarchical clustering over k-mean when visualization cluster relationship? The difference between k-mean clustering and hierarchical clustering. clustering approach. Centroid-based partitioning or hierarchical algorithm bottom-up or diverse top-down. Number of cluster predefined in k-mean cluster must be specified. No need to specify the number of cluster upfront in hierarchical. Cluster shape. In k-mean clustering, it work best with the spherical cluster. Hierarchical clustering can handle arbitrary shaped cluster. Output flat partition of data into k cluster or dendrogram tree structure showing cluster hierarchy. Computational complexity depends on k and iteration. It's more computationally expensive. Initialization sensitive to initial centroid selection or hierarchical clustering. No initial selection required. Handling outliers. K-mean clustering sensitive to outliers. Outlier affect centroids. Hierarchical clustering more robust to outlier. Outlier are merged with nearest clusters. Scalability. K-mean clustering better for large datasets. Hierarchical clustering not ideal for very large dataset. Cluster and relationship. K-mean clustering does not provide information on cluster hierarchy. Hierarchical clustering shows relationship between clustering in the form of dendroid. So this is the difference between of k-mean clustering and hierarchical clustering. Now let's discuss the advantage of hierarchical clustering over k-mean clustering when visualization cluster relationship. Dendrogram representation. Hierarchical clustering reduces dendrogram, which visually shows the hierarchical structure of cluster. This allows you to understand how clusters relate to each other at a different level of granularity, which is not possible with k-mean clustering. No need for predefined cluster. Unlike k-mean, which require the number of cluster k to predefined hierarchical clustering allow the user to decide the number of cluster at any level of by cutting the dendrogram. Better insight into cluster relationship. Hierarchical clustering gives a clear view of how clusters are nested within the each other, providing a deeper understanding of the similarities and differences between clusters. Flexibility with arbitrary cluster shape. Hierarchical clustering can handle complex shapes of cluster, unlike k-mean, which is assumed clusters are spherical. This flexibility allows hierarchical clustering to represent real-world data more accurately. So this is the advantage of hierarchical clustering over k-mean clustering. So this is all about our question number 4. Now, let's discuss our question number 5. Explain the concept of linear regression, how the best fit line is determined. Write the algorithm for linear regression for a given input data points x, y. Concept of linear regression. Linear regression is a fundamental statistical technique used to model the relationship between two continuous variables by fitting a linear equation a straight line to observed data. The goal is to predict the value of dependent variable, also known as target or response variable, based on the value of independent variable, also called the predictor or feature. In simple linear regression, there is only one independent variable x and one dependent variable y. The linear model assumes a relationship of the form y equal to beta 0 plus beta 1 x plus y equal to divide by beta 0 plus beta 1 x plus is ipsen, where y is the dependent variable, the variable we want to predict, x is the independent variable, the predictor, beta 0 is the intercept, the value of y when x equal to 0x. Beta 1 is the slope, the rate of changes in y for each unit change in xx. Ellipsion is the error term representing the difference between the predicted value and the actual value. The equation represents a straight line that best fits the data point. Determining the best fit line. The objective of linear regression is to determine optimal value of parameter beta 0 and beta 1 that minimize the error between the predicted value or of yy and the of actual values of y. This is typically achieved by using a method called ordinary least square OLS, which minimizes the sum of square error SSE. So this is the formula to calculate SSE, where YIY is are the actual data points, XI are the corresponding independent variable values, and beta 1 and beta 0 are the predicted value. To minimize the SSE, we calculate the value of beta 0 and beta 1 using the following formula. For calculate beta 1, this is the formula to calculate beta 1, and for calculate the beta 0, so this is the formula to calculate beta 0. NN is the number of data points. Linear regression algorithm step by step. Input data. Given in data points x1, y1, x2, y2, up to xn, yn. Calculate the required sum. Summation of xi divided by sum of x equal to sum of values of xx. Summation of y divided by sum of y, sum of all values of yy. Summation of x2 divide by sum of x2, sum of all square of all summation of x square divide by sum of x square, sum of all squares of all values of xx, sum of product of x y, sum divide by sum of product of x and y, sum of product of x of corresponding xx and yy. Calculate the slope beta 1 using the formula above and calculate the beta 2 using the formula above. Output the model, the linear regression model y equal to beta 0 plus beta 1 xy equal to beta 0 plus beta 1 x. Explanation of algorithm. Sum calculation. First we calculate the sum of x y, x square and x square and xy, which are used in the formula for beta 1 and slope and beta 0 interslope. Slope beta 1. Use the formula, we calculate the slope of best fit line, which represent how much yy changes for a unit change in xx. Intercept. Using the formula, we can calculate the intercept, which represent the value of yy when x equal to 0x. Return. The algorithm return the parameter beta 0 and beta 1 which define the linear regression equation. This is the example of above to calculate the sum of linear regression. So this is all about our question number 5. Now let's move to next question. Question number 6. Write an algorithm to create two clusters from 2, 4, 10, 12, 2, 20, 30, 11, 25. Write the output of each round. K-mean clustering algorithm for creating two clusters. The K-mean clustering algorithm is an iterative method used to partition data into KK cluster, where each data points belong to the cluster with the nearest mean. In your case, we want to create two clusters from the dataset 2, 4, 10, 12, 2, 20, 30, 11, 25. Steps in the k-mean clustering. Initialization k centroids. We randomly select 2 points as initial centroids. Second, assign points to the nearest centroid. Each point is assigned to the cluster whose centroid is closest. Third, we compute centroids. After all points are assigned to cluster, we calculate the mean of the points in each cluster, which become the new centroid. 4. Repeat step 2 and 3 until the centroid do not change significantly between iteration convergence. Algorithm step. Choose k equal to 2 since we need to cluster. Initialize two centroid randomly from the data points. Assign each data points to the nearest centroid. Recalculate the centroid based on the points in each cluster. Fifth, repeat the process until the centroids stop changing. Initial data set 2, 4, 10, 12, 2, 20, 30, 15, 25 divided by 2, 4, 10, 12, 2, 20, 30, 11, 25. Algorithm. Round 1. Choose the initial centroid. Let's choose 2 and 20 as initial centroid. C1 equal to 2 and C-1 equal to 2. Initial centroid for cluster 1. C2 equal to 20 and C-20 equal to C-2 equal to 20. Initial centroid for cluster 2. Assign points to the nearest centroid. For 22, mod of 2 minus 2 equal to 0. Mod of 2 minus 2 equal to 0 nearest to 2 assigned to cluster 1. For 44, 4 minus 2 equal to 2 and mod of 4 minus 4 equal to 2 and 4 minus 20 equal to 16. 16 nearest to 2 assigned to cluster 1. Same process we repeat. Now cluster assignments. Cluster 1 equal to 2, 4, 10, 2 and cluster 2 equal to 12, 20, 30, 11, 15. By doing same, by repeating same step again and again, we have so by repeating the same step, we have cluster assignment cluster for cluster 1, 2, 4, 10, 2 and for cluster 2, 12, 20, 30, 11, 15. Recompute centroid. C1 equal to 2 plus 4 plus 10 plus 24 e- equal to 4. So recompute centroids. For C1, we have output 4.5 and for C2, we have answer called 19.6. Now round 2, new centroid. C1 equal to 4.4. Now in round 2, our C1 equal to 4.5 and C2 equal to 19.16. So by doing same process, we have the cluster assignment called cluster 1 2.4 2, 4, 10, 2, 11 and cluster 2 12, 20, 30, 25. Now we have recompute centroids for C1 equal to 5.8 and C2 equal to 21.75. For doing round 3, now new centroids are C1 equal to 5.8 and C2 equal to 21.75. Assigning these points to the nearest centroids, we perform the same step and find out the cluster assignment. For cluster 1, 2, 4, 10, 2, 11 and cluster 2, 20, 30, 25. Now recompute centroids are C1 equal to 5.10 and C2 equal to 2.25. Convergency. At this point, the centroids have established and no further changes are made in the cluster assignment. The final cluster are for cluster 1, 2, 4, 10, 2, 11, and cluster 2, 20, 30, 25. Final output equal to for cluster 1, 2, 4, 10, 2, 11 with centroids 5.8 and cluster 2, 20, 30, 25 with centroid 25. This includes the clustering process using the K-mean algorithm. So this is all about our question number 6, and here we discuss our second external examination question paper. If you have any doubt, then comment in the comment box. Thank you for watching the video.